Exercise 1.4. Please complete this exercise and some solve problems. Next point is second order derivative. Question: find second order derivative. Find second order derivative. X square into e raised to x. As usually, y is equal to x square e raised to x dy by dx is equal to, these are two functions in the product form. So u into v rule, u derivative of v e raised to x derivative v raised to x plus e raised to x v derivative of u. X square derivative is 2x. Next, second derivative, that means derivative of dy by dx. Derivative of dy by dx is d2y by dx square. Now first take derivative of this plus derivative of these terms. So is equal to derivative of this term. Here again there are two functions in the product form. So use u into v rule. U derivative of v e raised to x derivative is e raised to x plus v e raised to x derivative of x square is 2x plus first u. Again here there are two functions in the product form. So u into v rule, u e raised to x derivative of v. Derivative of v is 2 into derivative of x. Derivative of x is 1. So 2 into 1 is 2. That means derivative of this 2x is 2 plus v. Derivative of u. Derivative of e raised to x is e raised to x is equal to see first term x square e raised to x here e raised to x 2x e raised to x 2x, that means 2 e raised to x 2 e raised to x 2x e raised to x 2x plus e raised to x 2x 2 times e raised to x 2x, and here is e raised to x into 2. And this is the answer. If we see, then in this answer we take e raised to x common and simplify. So here x square 2x 2 into 2x, that is 4x 2. Answer e raised to x square plus 4x plus 2. if ax square plus 2hxy plus by square is equal to 0, so that d2y by dx square is equal to 0. This is very important question. See how to solve. First take ax square 2hxy plus by square is equal to 0. First take this statement. Split these 2hxy as ax square 2hxy, that means hxy plus hxy plus by square is equal to 0. Next is take these groups. In the first group we see x is common, so take x common, a remaining x plus x outside hy, x common, so we will return plus here y common hx, y common, b remaining y common plus b remaining y is equal to 0. Next is y hx plus by is equal to, this term to this side it becomes minus x plus hy. Next step is hx plus by, this term here, right bracket. This term to this side becomes divided by, this term to this side becomes divided by, see, we have to find y upon x, so y, this term take to this side, with negative side it is minus divided by y, this term to this side with negative side divided by is equal to, here remaining ax plus hy, this term to this side becomes divided by hx plus by. See once again arrangement, y, this term which is in the multiple form here, it comes to this side at denominator with negative sign, so minus x is equal to this remaining term, this term to that side becomes divided by. Now remember this value which we write here, minus y upon x is equal to ax plus hy upon hx plus by. Write this. Remember this is some value we write there. Next step is take this statement again and differentiate with respect to x. Differentiate with respect to x. Now start differentiation. A constant. Derivative of x square is 2x. A constant. Derivative of x square is 2x plus 2h constant. in the bracket x and y terms remaining, x and y terms remaining, and we have to take derivative of x into y according to u into v rule. U derivative of v dy by dx plus v derivative of u, x derivative is 1, plus next term derivative b constant, y square derivative is 2y, y derivative is dy by dx. RHS derivative of 0 is 0. See once again how we take derivative. A first term's derivative, a constant derivative of x square is 2x plus 2h take common constant, and inside there are two functions x and y, and they are in the product form, and we have to take derivative. So according to u into v rule, u derivative of v derivative of y is dy by dx plus y derivative of x is 1 plus b constant, y square derivative is 2y, y derivative dy by dx is equal to 0. In all the term there is 2 constant, so take outside x, h, x dy by dx, y into 1 is y, b 2 common, y dy by dx is equal to 0. 2 to this side goes at denominator and it becomes 0. So x multiply inside by h, hx plus dy by dx, x plus hx dy by dx plus hy plus by dy by dx is equal to 0. Take dy by dx terms. First is x, right, plus hy, plus from these two terms we take dy by dx common. What are the remaining terms? Here hx plus here by dx is common, so it is equal to 0. X plus hy, from these two terms take dy by dx common, hx plus by. Right here bracket hx plus by, hx plus by dy by dx. This term to that side becomes minus ax plus hy. This term here, this term to that side becomes minus ax plus hy. Therefore dy by dx is equal to minus ax plus hy. This term to this side goes at denominator hx plus dy. Dy by dx is equal to, now there is value of this term c, ax plus hy, hx plus by. From this find value of this is, so here write minus if we take here, then here also we take minus, so it becomes plus, so y upon x, and this becomes minus ax plus hy, hx plus by. See once again, here we require this minus, so if we take minus here, we take minus sign to this side here also, we take minus sign this side also, so it becomes plus, and we get value of this is, we have to put dy by dx is equal to minus this value, that means y upon x. We find this value, take negatives of both sides, this negative, here originally negative and negative become positive, and we get value of this term is this term, so dy by dx, this term's value is y upon x, but we require d2y by dx square, that means we have to take again derivative of this, so dy by dx derivative is d2y by dx square is equal to, this is according to quotient rule u upon v, so we write v, derivative of u, derivative of y is dy by dx, minus v derivative of u minus u, derivative of v, x derivative is 1, x square. Once again, y upon x, derivative v, derivative of y is dy by dx, minus y derivative of x is 1 upon x square. But look at this step, see d2y by dx square is equal to x, dy by dx in this step, which is y upon x. Dy by dx, which is y upon x, minus y upon x square. Once again, remember this step, and in this step x, put value of this term, which is y upon x, minus y into 1 is y upon x square. X get cancelled, remaining terms y minus y upon x square, y minus y is 0 upon x square. Now this is d2y by dx square, 0 upon x square is 0, 0 upon x square is 0, and this side is d2y by dx square. We want to show d2y by dx square is equal to 0. Remember, this question is very important, which is solving two steps. Remember, splitting step and taking derivative. Next is question. Successive differentiation, nth order derivative. Next point, successive differentiation. Nth order derivative. Next one is also interesting point, successive differentiation, nth order derivative. Question is find nth order derivative. X raised to n. Start y equal to x raised to m. First derivative dy by dx m x raised to m minus 1. Second derivative m constant. Derivative of this term is m minus 1 x raised to m minus 1 minus 1, that means m minus 2. Third order d3y dx3, m constant, m minus 1 constant. Derivative of this term is m minus 2 x raised to m minus 2 minus 1 m minus 3. Now we want to find in this way d raised to 4y, dx raised to 4 and all that. And nth derivative is dny upon dx raised to n. How it comes? m minus 1 m minus 2 in this way. What is nth term? See nth term x m raised to m minus n is there. It becomes, and then here is from this term. How we get this term? If we add 1 here, then we get m minus 2. So if we add 1 here, write m minus n plus 1. This is the nth derivative. Nth derivative. See third derivative m minus 1 m minus 2. And observe this term. Third derivative, so here is 3. Nth derivative, so here is n. What is the difference between these two terms? We get this term by adding 1 here. So we add in this term 1. So we get this term. In this term we add 1. M minus n plus 1. Try to understand. Third derivative here is 3. So our nth derivative here is n. How this term becomes? By adding 1 here. So this term by adding 1 here. M plus n minus 1. And this is the nth derivative. of x raised to m. M minus 1, m minus 2, m minus n plus 1, x raised to m minus n. Remember this method. Next is find second derivative. X raised to 3 x raised to 3 log x. Second derivative we have to find. Write first y is equal to x cube log x. If we see, then here there are two functions in the product form. So dy by dx is equal to u, derivative of v log x, derivative is 1 upon x, plus v, derivative of u, x raised to n rule, 3x raised to 2, 3x raised to 2, 1x cancel, so here is x square only, 1x cancel, x square into 1 is x square plus log x, 3x square. This is dy by dx. We find second derivative now, d2y by dx square, d2y by dx square. This is, before that, see this step, x square is common, here is 1 plus 3 log x. This is the step. Next simplification, x square common, so here is 1, here is 3 log x. That means actually dy by dx is equal to this term x square 1 plus 3 log x. But we require second derivative, that means d2y by dx square. Here these are two functions in the product form, so use u into phi rule, u x square, derivative of this term, derivative of this is 0, don't write, derivative of this term plus derivative of this term, derivative of this term is 3, constant, log x derivative is 1 upon x right here. See once again, derivative of this 1 is 0, so 0 plus something is there. So something, that means derivative of this term, derivative of this term is 3, constant, derivative of log x is 1 upon x right here, plus this term derivative of this term x square, derivative is 2x. This is second derivative, but see what are the simplifications. 1x get cancelled, remaining is 3x plus multiply inside by 2x, or write as it is, multiply inside by 2x, 2x plus 6x log x multiply inside by 2x, 6x log x, and from this here we get 5x plus 6x log x, and next step of simplification is take x common, so 5 plus 6 log x. This is the answer. X common, 5 plus 6 log x. This is the answer.